Hello and welcome to another walkthrough video of IAL Edexcel AS Level Physics. And today we are going to do paper 1 of January 2024 WPH1101 of AS Level Physics. And what's very special about today's walkthrough is this is the officially marked question paper of one of my students, and he asked for the rechecking of his question paper back in January 2024. And today I'm sharing it with you just to give you an idea that how usually Pearson examiners check or mark your question papers, and then you will have an idea that how can you avoid silly mistakes so that you may not lose your precious marks. So let's start. And before going into details, if anyone out of you or anyone in your friends and family members need any help in physics, please reach me out on the given numbers on the left hand side of this video and the description. And also like and subscribe and share my channel with your friends and family members. So question number one, they are asking for the units for the stress. All you need to do is just write the unit formula, and he did it well, so he got 1 mark in that, and you can see this mark here. Then question number two about vector quantities, and of course these are the 3 vector quantities. So he did it right, that one as well. Therefore, he got 1 in that too. Then question number 3 was you got the force, you got the energy, and you have to find out the extension. So extension, he got it very well. Again, he got 1 mark, no problem with that. Then the question was that a body is moving at a constant speed. Okay, and then he started to climb on the mountain. Okay, or some inclined surface, and they asked for the power time graph. So for that, he got the answers to be correct as well. And if you want to know how this answer is correct, then you need to analyze that if this is time and this is work, then what will be the power? Power will be the gradient of this graph, right? So power is gradient, and it will be equals to this. And if we take the analogy of velocity time graph here, just consider velocity time graph for the time being. Uh-oh. Okay, so what is actually the graph for acceleration time for this velocity time? You got straight line, okay? Because the gradient of velocity time is actually equals to acceleration. Similarly, for work time graph, the gradient of power time graph will be straight line, right? Like this. So because he's doing some constant work and is moving at constant speed, therefore the gradient will be like this straight line when he was not climbing. And when he started to climb, of course he's climbing at a constant rate, he's moving at a constant speed, but he's investing more power, so therefore power consumption will be at constant rate, just like acceleration. Okay, so therefore the reason for option D is the reason of the analogy with velocity time and acceleration time graph. Okay, so in this question they were very smart. They're saying the student is measuring, student is dropping the ball. So when a student is dropping the ball, he is actually ignoring the air resistance. Okay, so when dropping the ball and you're ignoring the air resistance, you're measuring velocity and time, two things. Okay, no air resistance. So in actual values means there will be some air resistance and there will be some delay in reaching the ball to the ground. So they are saying compare your actual values with the student measured value. So student neglected the air resistance, but in actual there will be a resistance. Therefore, when there will be an air resistance, of course it will take a little more to reach the ground and the speed will be less. Therefore, the option was C. Again, this was the right answer by the student. In this question, again, you need to, although he did not very well explain the composition of the vectors here, because the vector here is in this form, this is T. So one component is this and the other component is this. This is how you need to do this, the component, because these two components are always at 90 degrees to each other, number one, and they are always directed towards the direction of the parent vector. So parent vector T is two components will move into the direction of the parent vector according to head to tail rule. Okay, remember, having 90 degree with each other. Now here you have 80 and here you have 90. So the side where you have the angle theta and the 90 is always your base. So, and base always reflects cos theta. Okay. Now you see that there are two forces moving up, like t cos 80 and here t cos 80. So you will just write upward forces equals downward forces. So upward forces t cos 80 plus t cos 80 and downward forces w. So therefore you got this answer, which is again correct. Very good. But I was just explaining it. Okay. So here they ask for that which of the following gives the stiffness. Stiffness means K, right? So F equals K delta X, right? And K is actually equals to F over delta X. So here Y will give you a rise and delta X will give you run. So rise over run is actually gradient. Okay. Now this part actually shows actual length and this part shows extension. So for example, this was 2 meter and this was 3 meter. So this rise in the curve is actually giving you the extension. Okay. Now, so he answered question 7 right again. Here they asked for they have provided you the density, they have provided you the weight, and they asked for the which expression gives the length of each side of the cube. So you have the cube. First of all, the volume of the cube is x into x into x, which is x cube. Okay. Now density is actually mass over volume. But you don't have mass, you have weight. So mass is actually equals to W over G. So you will write right? And then they're asking for the side of x, length of each side. Therefore, you need to find out the value for volume first. So it will be rho v, and then it will be x cube, because volume is equals to x cube over rho v. Then you need to do cube under root, and that will give you. Okay, so this option is again correct. This was a wrong answer by the student, because in such questions, usually most people confuse. Now I'll explain each option one by one, so that you may not do the mistake in the exam. Okay, first one, P has greater breaking stress than Q. What exactly is the point showing where the body is breaking? This is the point. And this is the point, because when the body breaks, no more stress, no more strain, no more graphical extensions or contractions will be shown, because here the body is break. It means there is no point of having the graph going on further, because no more extension, no more strain, because body is already broken, right? So at this point you are stopped, means the body is now broke. But here the body is not broke, it is deformed plastically, not elastically, but plastically. Okay, elastically means it can restore 100% back to its original shape. That is called elastic. But plastically means it is permanently deformed but not broken. So P has greater breaking stress than Q. What is the value of breaking stress here? You need to extend it up to here, and you need to extend it up to here. So you can easily see that P's breaking stress is smaller and Q's breaking stress is larger. So this option is wrong. Then P has greater breaking strain than Q. Again, strain is on the x-axis, so you need to drop this value here, and you need to drop this value here. So again, you can see that the breaking strain is greater than Q for P. Again, this is not the right option. P has greater yield stress. Okay, yield means the point where body starts losing its elastic deformation, and that point starts from here, because no more straight line curve you are seeing. These straight line curves are basically show the Young modulus, right? Where Hooke's law is valid. The point where Hooke's law is not valid, you will lose the straight line graph, and it will turn into some unusual graph or not straight line graph. So this is the point where we are getting unusual graph or yield stress. I mean, it is a point where bodies start losing its elastic deformation. It enters into the plastic deformation region. So you can see that this is the yield stress of P, and this is the yield stress of Q. So again, the yield stress for P is greater than the yield stress for Q. So this was the right option. And here P, they're saying yeah, in the option, they're actually saying P has lower Young modulus than Q. No, it is again not correct, because it is steeper and it has large gradient. Okay, large gradient means large Young modulus, because Young modulus or gradient is actually rise over run. Rise is your stress and run is your strain. So stress over strain actually equals Young modulus. So gradient in another way around is giving you the Young modulus. So its P's graph is steeper, therefore its Young modulus is greater than Q. So this option is not correct as well. So the only option for this question was C. In this question, they asked that which of the following expressions gives the distance moved by the object. So again, they played very smart in here, and you need to remember that this is the acceleration time graph, okay, AT. And for constant acceleration time graph, you have another graph of velocity time which is moving like that. I showed you in the first or second question like this concept, okay? So area under velocity time graph is actually giving you the distance, and you need to find the distance here, okay? So distance is actually half into VT, okay? And according to acceleration time graph, if you find out the area under velocity time graph, sorry, acceleration time graph, you will get A into T. And area under acceleration time graph actually gives you V. And this area, sorry, I need to correct it. This area is actually given as X, and this acceleration times time is actually speed. So X equals V. Now all you need to put V as X. Okay, so this should be your answer. And the answer was D. So this question has a lot of chance to come in this exam 2025, because I have not seen this question in a while. So I hope so this question is coming in this January 2025. So you need to take care of this question. So they're saying a student applied a force F to the rubber band. The student measured the corresponding extension delta X as F was increased and then decreased. The graph shows how delta X varied as F was increased and then decreased. Okay, so this is actually your extension, right? And if you see on the y-axis you have force, and if you see on the x-axis you have extension. So if you find out the area, what the area will be equals to F into delta X. And what is F into delta X? It is actually energy, force into displacement, work or energy. It is same, right? So we can write that energy or extension energy required to do the extension, right? So extension energy is F delta X, right? So all this area under the graph is giving you the area energy required for the extension. And the second curve you can see, which is coming like that. Okay, maybe I need to use another color like this one. Okay, so this is contraction energy. Body is contracting again. Contracting means compressed again. Contraction energy, and the contraction energy is actually again given by F delta X. Okay, now you can easily see that the contraction energy is smaller, because area under the contraction curve is small than the extension curve. So we can easily see that there is an area which is gone somewhere, and we don't know where actually this area gone. This area, purple. So this is the energy lost in heat or friction, whatever. Okay, you need to remember that. Now come to the question. A student applied a force F to a rubber band. The student measured the corresponding extension delta x as F was increased and then decreased. The graph shows how delta x varied as F was increased and then decreased. Okay. State how the graph shows that the rubber band deformed elastically. Do you see that the body started from zero? The body started from zero and came back to zero again. You see, it started from zero and coming back to zero again. It shows that the body is restored into its original position. Therefore, it shows that it was deformed elastically. So you will write that the answer to this question. It was not correct. This is correct. Body or rubber band is stored back to its original shape or position. Okay, which is actually zero. Okay. The burden on the rubber band as F increased is greater than the burden by the rubber band as F was decreased. This is what I've shown, right? You can see that the red area, which is required for extending the rubber band, is higher than the green area, which is required for decreasing or shrinking the rubber band again back to its original shape. And they're asking there is a difference in these two values because of the heating occurred. This determine the energy that caused heating as F was increased and then decreased to zero. So you know that this area, this purple and the area which is the mix of red and purple lines, this is the area which is not occupied between increasing force and decreasing force. So you need to count the boxes here and you need to find out the area for each box. So I have done that for you and you can do it later on your ease. Total boxes were 18. Okay, and each box has area of, each box area is 0.25 into 10 raised to the power minus 2 meter. Why I did that? Because here the length is in centimeter. Usually students also do this mistake because they don't understand the unit. And when you are solving questions in physics, you need to use SI units, which is meter, kilogram, and second. So therefore, you have to convert the centimeter into meters. Okay. So this is the area of one. So all you need to do is just to multiply this with this, and you will get the energy lost in heating. Okay. So in a game called darts, metal darts are thrown towards the dartboard. The dart hit the dartboard as shown. A dart is thrown with a velocity 15.6 at an angle of 5 degrees to the horizontal. The dart travels a horizontal distance t to the dartboard as shown. Just before the dart hits the dartboard, the vertical component of the velocity of the dart is 0. The air resistance acting on the dart is negligible. Show that the time taken for the dart to reach the dartboard is about 0.14. So again, here my student got 3 out of 3 because he did it exactly correct. Because when you are talking about vertically moving body, your acceleration is actually minus 9.81. So he got it. Then vertical component was 0. Okay, so you need to find, this is actually your vertical component, this is your initial vertical component ui, and this is your minus g. Okay, so you can write this as well like this. This is vertical component of speed final, this is initial component of speed y component, this is your gravitational acceleration. Just put in the values and you will get the time. This is actually equals to 0. So calculate the horizontal distance traveled, uh, distance d traveled by the dot. So again, it was very simple. You need to find out the distance, which is equals to ux times t. Ux means u cos theta because horizontal component you need to use, and he did it exactly correct. So he got the right answer to be 2.15 meters. Full marks for this question. So in this question, he got 3 marks, 3 out of 3. So they're saying that you have a diver here, and it has part of this as air, this is air, and this remaining part is water. When you squeeze the bottle, this goes down, and they're asking you why. So it is very obvious that when it was floating, upthrust was equals to weight. And when you squeezed it, more water went into that. It means it weight was now increased, but the upthrust was same. So because it has more weight now, because more water inside the diver, so it weight is now out bounding the upthrust. Therefore, it will sink down. And this is what the reason he explained here, and he got the full marks. Okay. So in this question, they're saying a child's slide has a vertical height of 1.7 meter as shown. A child starts from the rest at the top of the slide and moves down the slide. The resistive forces acting on the child can be ignored. Explain why the equations of motion should not be used to determine the maximum speed of the child. You should consider the shape of the slide. Okay. Now you see he explained the answer very well, but maybe he put too much information or mixed up the information. Therefore, he lost 2 of his marks here. You see, first of all, you need to know that the equations of motion are always applied on a constant acceleration. So because of this shape, the acceleration will not be constant. The only reason you have to mention here was acceleration is not constant due to shape of the slide, number one. And the second one was gradient is different. Gradient is different across slides. And third one is SUETs only valid for constant acceleration. Okay. Without constant acceleration, you cannot apply the SUETs. So these were the three reasons, but he mentioned only acceleration, nothing else. He said no constant acceleration, therefore the equations of motions cannot be applied. Would be inaccurate answer. He just explained that. But he need to use these three separate points in a separate way. Because when you're asking, when you're given 3 marks for a question, it means you need to write at least 3 points. Okay. So he just mentioned 1 point, therefore he got just one number. So you need to be very careful with that. Now mass of the child is 24, and he got the answer to be very correct because change in potential energy equals change in kinetic energy. It is starting from here, and you got the right answer. Just put in the values, and you got the answer. So therefore, you got the right answer here. And for this, he said that slide Y is steeper and the slide X is not steeper, so it will take more speed, which is again wrong because if you see the previous part, you are saying yourself that V square is actually equals to 2GH. Where is mass in this equation? No mass. No mass dependence for the speed. Okay. So you will say that the speed of the speed of the object is dependent on the height. And the last point, if these two have the same height, it means they will reach the ground with the same speed. Okay, because the speed is actually function of height, only height, because you get ke equals change in pe, then half mv square mgh, and v square equals 2gh. Mass cancelled. Okay, so v equals 2gh. Okay, therefore the speed is independent of the mass. Therefore, he got here 0. So you need to be very careful. A student investigated a small ball bearing falling through the liquid to determine the viscosity of the liquid. State the condition needed for Stokes law to apply for this. There needs to be a small ball with a low, uh, with a low relevant, with a small turbulence, I believe, and the ball should be traveling at a low velocity. This is the point actually. Small is already mentioned here, so you don't need to mention that again. And there should be a laminar flow. This is one. So if you just write this and this, you will get 1 mark. But here he explained these two reasons, therefore he got 2 marks both. Complete the free body force diagram for a ball bearing when falling at terminal velocity. Okay. So this is another silly mistake that usually students do. Although the diagram is perfectly well, but if you see that the length of the vectors here are not equal, the weight is equals to upthrust. So which vector is actually balancing out the drag? Sorry. So perfect answer for this question was to make equivalence for drag and upthrust. Okay. Now when you add these two, you will get a vector like this, which is actually equals to weight of the vector. So if the total length of these vectors is 3 centimeter, it should be 3 centimeter as well. Okay, you need to remember that. So that will now show that the sum of upward forces are equal to sum of the downward forces. But here it is shown vectorially that the upward forces are more and the downward forces are less. Therefore, he got 1 mark here. So you don't need to do it. You need to do this one. Okay. The student thought that the liquid she used must be glycerol. She made measurements to determine the terminal velocity of the ball bearing. Okay, the terminal velocity of the ball bearing was 0.0824 meter per second. Deduce whether the liquid she used was glycerol. Density of the glycerol given, radius, weight, and viscosity is given. Okay, all you need to do is just to find out first of all the drag and the upthrust is equals to weight. From here you will find out the drag. FD. When you find out the drag from here, then find out the drag from 6 pi r eta vt as well. If these two answers are equal, it means the liquid was glycerol. Or you can find out by putting this value here. Just find out the drag from here first. Put in drag value here and find out eta by doing it. FD equals 6 pi r vt equals eta. So if you where's viscosity? Yeah, this one 0.94. It means it was glycerol. So he did it well and he got the full marks. Okay. Question number 16. A skittle is a wooden object that can stand upright on one end. In a game of skittles, a ball is thrown at some skittles to knock them over as shown. The diagram below shows the ball just before it collides with a skittle. The graph shows how velocity of the skittle varies with time. The time shown on the graph just before the ball hits the skittle. Okay. Determine the average acceleration of the skittle during the collision. So he got 2 marks out of 3. The reason why, although he took the gradient very well, but you see the time here is in millisecond, which means 10 to the power minus 3, and here was meter per second, but he took the value of time as it should be 10 to the power minus. You have to be very careful with your measurements. Okay. Therefore, he lost 1 mark in this 3 out of 2. Explain how Newton's second law and third law of motion apply to a ball and the skittle during the collision. in this star questions, you have to remember if you answer 10 by 10 correct, but not in a logical sequence. For example, you are explaining something earlier which is happening in real and later on stages, then you will not gain marks. You have to explain the question and its answer in a sequence, in a logical sequence. You cannot explain things which are happening later on at early stage. Okay, so now you see why he got 3 marks. I will explain you. As the ball hits the skittle, it exerts a force on the skittle. And the Newton's third law, we know that the skittle exerts the same magnitude of force acts the ball, but in the opposite direction. Force exerted on the skittle by the ball comes to accelerate due to F equals ma. The magnitude of force that hits the ball is proportional to the acceleration of the skill. But he did not mention here Newton's second law of motion. Okay, he did not mention that equal and opposite forces are acting. Which one was the action force, which one was the reaction force? You see that? So how would you write the answer to this question? Number one, ball strikes skittle and apply action force on skittle. Number two, skittle in return apply the same reaction force on ball, but in opposite direction. Okay, three, according to Newton's third law, these two forces are equal in magnitude and opposite in direction. Okay, now this was actually Newton's third law. For second law, now we'll talk about that. Due to these forces, due to these forces on each other, skittle will accelerate and the ball will decelerate, right? According to Newton's second law of motion, according to Newton's second law of motion, the acceleration is produced in ball and skittle according to F equals ma. Is produced in ball and skittle. This acceleration is given by A equals F over, and that's it. So that was the logical answer to this question. Okay, I hope you understand that. The ball is thrown again and collides with another stationary skittle. During the collision, the horizontal velocity of the mass changes from 7.2 meter seconds to 1.6 meter per second. The horizontal velocity of the skittle immediately after the collision is 3.1 meter per second in the same direction as the ball. Determine the mass of the ball. Mass of the skittle is this. So again, in this question, you just need to apply momentum before collision equals momentum after collision, and then find out the mass, which was very much right. So he got 8 marks out of 16 marks, and he lose 3 marks here and 1 mark here. Okay. Question number 17. A student determined the young modulus of the material in the form of a wire. The student used a micrometer to measure the diameter of the wire. Describe how students should check the wire is uniform. Check that the wire has a circular cross section. Wire is uniform means it has same thickness all along. Okay, so this is uniform and this is not uniform. You can see from here it is not thick, from here it is thick. So if you measure the diameter here, here, and here, and it has a different measurement result for each length, for each thickness, sorry, it means the wire is not uniform. Okay, but if you rotate it and then measure the thickness, then it will give you an idea that the cross section, I mean, the wire is equally round from all sides, or there is some dip in the wire. For example, you have the wire which is of same thickness from here, but here it has some dents. So when you rotate the wire and move the wire, this point here, if you move it and then measure the thickness, it will show variable thickness, but here it will show same thickness. So for example, if you measure these two sides from a micrometer, it will show same thickness. And when you rotate it and bring this side on the top and then measure the micrometer using the micrometer, it will show that there is some change in the diameter because the wire is not uniform from this point. So therefore, in order to make sure that the cross section is uniform, you need to take readings at different orientations. Take multiple measurements at various orientations. Okay, and for that, take measurements in order to make sure that the wire is uniform, take measurements at various locations Okay, so this was point number one and this was point number two. And what he write actually, let's check. To check that the wire is uniform, the student should test whether the center of gravity is at the center of the wire at the body or no. To check the wire has a circular cross section, the student should use a micrometer. They have already told that you should use micrometer. So this was not the right answer by the student. Therefore, he got 0. The student hung a reference wire and the wire being tested from the ceiling. At the lower end of the reference wire, position fixed part of the vernier caliper. The student attached 100-gram mass hanger to a wire being tested. The initial reading on the vernier caliper scale was 0.0 mm as shown. He added masses to the mass hanger and measured corresponding external delta x of the wire using the vernier calipers. Then the student kept his feet away from the apparatus so that the masses could not fall on his feet. Explain one other safety precaution. Ensure that the wire is securely attached to the ceiling so that it does not fall all if too much weight is added. This is not the correct answer. The correct answer was to use goggles. Because if wire is broken, because if wire is broken, it may not harm the eyes. So this was the right answer, but he wrote mysterious reason. Therefore, he didn't get marks in this question. Each time the student added more masses, delta x increases by a few millimeters. Explain why he should measure delta x using a vernier scale instead of a meter rule. Well, for me, the answer to this question was very much precise and correct, and I don't know why the examiner did not award him 2 out of 2. So the reason maybe for that is not more accurate. This is not correct. Actually, meter ruler, and vernier caliper both are correct. In more accurate means one equipment is giving you wrong answer, one is giving you right answer. This is the mistake maybe he did here. So rather writing more accurate, you need to write that this is the minimum reading you can take. Minimum reading from meter ruler is 0.1. Sorry. Okay. 0.1, and the minimum reading from the vernier calipers is from vernier caliper is 0.01. So you have to write resolution of vernier caliper is more than the meter rule. And second reason is extension is small, which is correct answer. Extension is small. So we need an instrument with greater resolution because we have a very small length as an extension. So we need a precise equipment which is having more resolution to measure the extension with greater resolution or least count. Okay. We call this minimum reading as resolution or least count. Okay. So therefore he lost 1 mark in here. Okay. From each mass added, the student determined the force on the wire. The student plotted the graph shown. Okay. The table gives you the Young modulus for some materials. Okay. Determine which material the wire was made from. So they have already provided you the graph. Okay. Right. So using the Young modulus, because on the y-axis you have extension and on the x-axis you have force, right? And you have the original length to be here and diameter here. So you can use the diameter to find out the area, and you can put the original length here and the extension from the graph and the force from the graph too, and just find out the answer for the Young modulus. And he got 106.8 gigapascal. And see, 108 gigapascal was according to was near to brass, but he wrote aluminum. And you know the reason why he did such silly mistake? Because he was in a hurry, because he took a lot of time in solving other questions while not having an idea that time is running out. So you have to be very much careful when you will become panic like him if you don't manage your time effectively. And when you don't manage your time effectively, you do such silly mistakes. He got answer which is very equal to brass, and he written that aluminum is the answer. Okay. A uniform door of width W is supported by two hinges, X and Y. X and Y are vertical distances L apart as shown. Okay. State the conditions needed for the door to be in equilibrium. Clockwise movement equals anti-clockwise movement. This is one of the condition, not the second condition. The second condition is sum of forces acting on the body is 0. Okay. So in other words, sum of forces and sum of moments should be 0. These are the two conditions for a body to be in equilibrium. Okay. So he wrote 1 and he got 1 mark. Give the meaning of the term center of gravity. Again, very much silly mistake. The point at which the body of and the weight of the object acts upon, not acts upon. Considered to act upon. This is very much important. This is keyword. Considered to act upon. Okay, because the center of gravity changes with the orientation. If a body is in standing position, the center of gravity will be up high, and if it is laid down horizontally, the center of gravity will come down. So it depends on your orientation. So therefore, we always say that the point where the weight of the object is considered to act upon is called center of gravity. And he knew that concept, but he lost 1 mark because he didn't write this keyword. You need to be very much careful with that. Okay. The diagram shows the forces acting on the door at each hinge. Okay. The mass of the door is 14.4 kg. The weight of the door causes the moment about each hinge. Show that the horizontal component of the forces of the hinge Y on the door is about 40 newtons. So he did this question wrong, and you have to do this question right according to the calculations. And how would you be able to do that? And I'm leaving this question for your practice because I'm running out of time. He just did something wrong with the question, and because he didn't attempt it well, he told me that I was having only 3 to 4 minutes left. So I did it in a haste, and he got this 1 mark here. So for that, you need to do clockwise moments equals anti-clockwise moments and find out the answer. Okay. And in the last part of the exam, you have to do the same as well. Okay. And finally, an identical door is supported by hinges that are much closer together. Explain how smaller values of L affects F and theta. You should consider moments about X. So again, you need to consider X. I mean, this point for answering this question, usually you have moment to be equals to RF sine theta or RF cos theta. And you need to check for X whether RF sine theta works or RF cos theta works. So they are saying smaller value of L affects F and theta. So L means this momentum R, and you need to check that moment is actually equals to R and theta, because they're saying bring cos theta down. So now if it is increasing, it should be decreasing, right? So when R is decreasing, F is increasing, number one. And number two, when theta is increasing, cos theta is decreasing, because cos 0 is 1, cos 30 is 0.86, cos 60 is 0.5, and cos 90 is 0, right? So it means when your theta is increasing, your cos theta is decreasing. And when your cos theta is decreasing, your force should be increasing as well. Okay. So that was the go through of January 2024 AS Level Physics. I hope you understand well. If you have any questions, you can reach me out. See you in the next video. And also, in the end, please like and subscribe my channel. Thank you very much. God bless you, and see you in the next video. Up till then, it's goodbye.